Just wanted to say before we begin is that this is not obviously meant to be a professionally made video. I've created it using my mobile phone, and its purpose is to demonstrate why it's necessary to use correction factors when testing Powersonic batteries with the ACT meter. First of all, I'd like to emphasize that there is no way other than to do the time-honored discharge test to measure the true amp hour capacity of a battery. The static laboratory testers that are designed to test for amp hour capacity is the Bytrode LCN 12-50. These are the blue testers that you can see right there, and these circuits will test VRLA batteries up to 1000 amp hours. Then there's the Cadex C7000, which is also a very accurate piece of testing equipment and is designed for laboratory testing of smaller SLA batteries up to 40 amp hours. This is the tester generally used for testing our fire and security batteries. With regards to portable battery testers, there are several available in the marketplace, including the Gold Plus and 612 ACT testers, which claim to test batteries for amp hour capacity within a few seconds. Unfortunately, they give inaccurate results, particularly on Powersonic 12 volt 17 amp hours and 12 volt 26 amp hour batteries. We have seen as a result lots of perfectly good batteries rejected by service engineers that use the ACT meter as a means for testing batteries. So to demonstrate, let's go ahead and test the Powersonic 12 volt 17 amp hour battery. First of all, we will measure the open circuit voltage of the battery to ensure it's fully charged using a good quality multimeter. Okay, the open circuit voltage of the battery is 13.09 volts, and that confirms that the battery is in a fully charged condition. So next we're going to do a test using the ACT Gold Plus tester. It's important that we get a good connection onto the terminals. Okay, the tester is going through a battery analyzing phase. The calibration is set at 0, and although this can be changed to suit specific batteries, this will be discussed in one of my other videos. So now we press the red button to start the test. And there you go, after a few seconds it's come up with a result of 14 amp hours for a 17 amp hour battery whose capacity has been previously verified using the Cadex analyzer. So again, I repeat, we are getting 14 amp hours on a 17 amp hour battery. The capacity result on the ACT meter is therefore around 18% lower than the true capacity. Okay, now let's test the battery with the ACT 612 battery tester. I believe that's the latest version of the ACT meter. Again, making sure we've got good connections on the terminals, which is very important. Okay, we'll press the red button to start the test. And again, we have got 14 amp hours. Again, 14 amp hours on a 17 amp hour battery. So it's clear that ACT testers cannot accurately predict the capacity of a PS12 170 battery. For this reason, and to ensure perfectly good batteries are not rejected, we've had to issue a correction factor of 1.2 for this battery. So 14 amp hours multiplied by 1.2 gives 16.8 amp hours, which is of course a more acceptable result. On the other hand, the Midtronics SCP-6-12 portable tester measures conductance, and by inputting a reference conductance value of a known good quality battery, the tester will compare the reference value with the conductance of the same battery model under test. The result is displayed as a percentage. Okay, we're connecting up the tester now, and it's important to ensure that we have good connections on the battery terminals. Now the reference value of a new good quality PS1270 is 400, so by inputting this number we can go ahead and test the battery. Okay, the Midtronics tester has output a relative conductance value of 119%, which indicates that the battery is not defective and has not reached the end of its service life. This battery therefore is in a good condition and does not need replacing. A reading of less than 60% is indicative of a battery that has reached the end of its useful service life. Okay, now here we have a Powersonic PS12260, which is a 26 amp hour battery. It's been previously tested, and the capacity has been verified. Okay, so if now we just first of all just check that the battery that's actually fully charged. Okay, there you go. It's the voltage is 13.16, which confirms that the battery is fully charged. And if we go ahead and now test with a ACT612 battery tester, like so. Okay, it's just powering up, and just take a few seconds to get the result. Okay, now if we press the red button, okay, we've got a result of 12 amp hours. Okay, so it's reading 12 amp hours on a 26 amp hour battery. If we do a similar thing with the Gold Plus, again just making sure the connections are good. Okay, it's going through the battery analyzing phase. Okay, press the red button to start the test. .11 amp hours. So again, it's showing 11 amp hours on a 26 amp hour battery. So it's clear that ACT testers cannot accurately predict the capacity of a Powersonic 12 volt 26 amp hour battery. And for this reason, and again to ensure perfectly good batteries are not rejected, we've had to issue a correction factor of 2.35. So 11 amp hours multiplied by 2.35 gives 25.85 amp hours, which is of course a more acceptable result. Okay, now if we test the same battery with the Midtronics SCP-6-12, okay, we'll make a connection to the terminals. Make sure we've got a good connection. And the reference value for this particular battery is 320. Okay, so we've got the reference value in there. If we go ahead now and press S to get a result. Okay, so the Midtronics has passed this battery. It's given a value of 116%, which proves that the battery is in good condition.